For parents and teachers, I wish to introduce some principles about multiplication, since next week we will enter into this topic with the children. There are several ways of understanding multiplications. One of them would be to make copies of something. Multiplying this string by 3 means to take 3 of it. If I want to know how much this is, I can add 5 plus 5 plus 5 are 15. This is a very logical way for a child of understanding multiplication. But we experience here the same thing as with the simple concept of adding and subtracting. When we advance a little more in math, this concept begins to fail. How much is minus 2.6 times minus 3.7? I cannot add this number 3.7 times, not speaking of adding it a negative number of times. When we get to this level, we will have to expand our idea of multiplication. But in this course, we will not yet enter into this. Another way of visualizing a multiplication is with a rectangle. This rectangle is 8 squares wide and 5 squares high. How many squares does it contain? This is a multiplication. With a rectangle, we can also visualize multiplication of decimal numbers and fractions. When we multiply our rods, we can put them in the form of a train like this. This allows us to compare the lengths of different trains. So you can see if the result of a multiplication is greater or less than the result of another one. Or we can arrange them this way. Now we have a rectangle. This allows us to illustrate some mathematical properties. Here we have rods of 4, 6 times. We can write it as 4 times 6. But I can form the same rectangle with rods of 6. Here we see that multiplication is commutative. 4 times 6 is the same size as 6 times 4. Multiplication is also associative. I can multiply this rectangle by 3. But I can also form first a rectangle of 4 times 3 and multiply it by 6. This gives a solid of the same measures. We can illustrate the associative law also in this way. Here I have 5 times 2. I multiply it by 4 and get this rectangle. But I can transform this into another rectangle. Now the height of this new rectangle is 5, and it is 2 times 4 units wide. So I can write it like this. But this new rectangle contains the same number of units as the first one, since I have not added anything to it nor taken away. The associative law is what allows us to multiply with tens and with hundreds. 30 is 3 times 10, so I can also associate the 4 with the 3 and finally multiply by 10. In our decimal system, it is easy to multiply by 10. We simply add a 0 at the end. Think how you would illustrate this operation with Cuisenaire rods. Let's examine 2 special cases of multiplication. Multiplication by 1. Any number multiplied by 1 returns the initial number. Therefore, the 1 is called the neutral element of multiplication. It is the element which has no visible effect. Multiplying a number by 1 is the same as if we had done nothing at all. When we compare this with addition, we see that there the 0 is the neutral element. Adding 0 is also an operation which has no visible effect. Now what happens when we multiply by 0? The result is 0, no matter the number we begin with. This is logical. Many times nothing is still nothing. Knowing this may save you some work. For example, what is the result of this multiplication? I don't need to begin multiplying 5 times 4, then times 3 and so on. I can see straight away that this multiplication contains a 0, so the whole product is 0. Here I have a sum. Let's multiply this sum by 6. How can we calculate the result? There are several ways of doing it. One possibility is this. We separate these two rectangles. The rectangle below is 10 times 6. The one above is 4 times 6. The result is both of them together. This means adding them. This is called the distributive law. It is called like this because we can imagine that the multiplication becomes distributed among all the summands. And of course, the same works with the subtraction. This is the principle behind long multiplications. Every large number is a sum. If we want to multiply this sum, we have to multiply each summand times 4. This is exactly the procedure we use for a long multiplication, only that we are used to write it in a more concise way. Let's talk shortly about the sign in a multiplication. We multiply a negative number. This we can still represent as a train on our number line. We see that the result is minus 20. So a negative number multiplied by a positive number gives a negative number. And of course, this is the same when we put the positive number first. This we know because of the commutative law. A special case is multiplication by minus 1. We can deduct a rule which is sometimes useful. Putting a minus sign before an expression means multiplying the expression by minus 1. This works also when the expression is a pair of parentheses full of other expressions. Then we can apply the distributive law. In week 2, we talked about the laws of signs for parentheses. Now we see that this is actually the same as the distributive law. As we progress in mathematics, we see that many topics are interconnected and are based on the same fundamental principles. When you can see these connections, math becomes easy. Now I leave you with 2 questions for investigation. How do you explain multiplication of a negative number by a negative number? You may say, the result is positive, I learned this in school. But to explain means to give a reason why. Can you explain why negative times negative must give positive? And the second question, according to the simple concept of a child, multiplication increases things. When we multiply a number, it becomes greater. But in mathematics, this is not always true. Can you give an example of a multiplication which decreases the initial number? We could say that this happens when we multiply by a negative number, because the result becomes negative. But I want to limit ourselves to positive numbers. With what positive number can I multiply, say 10, and the result is less than 10? Think about it and share your ideas in the discussion forum.